Okay, so in this video our goal is to kind of combine some things that we've talked about already, and specifically how to solve inequalities and how to solve absolute value equations. So in this video we'll talk about combining both of those, how to solve something that's both involving absolute value and that's also an inequality. So before we even do that, our rules are still the same. We still are going to cancel out the things being done to x by doing the opposite, and we'll still keep our equation balanced by doing the same to both sides. The strategy for absolute value is we need to clear away everything except for the absolute value. Okay, so for example, if I have absolute value of x plus 3 minus 2, if that was what I was of, I need to clear away that minus 2 before I can split it. Here's the other thing I want to point out with inequalities, and this is important to understand before we do either number 1 or number 2. Let's do a real simple example. Suppose I told you that the absolute value of x is greater than 3. So remember we said before that absolute value refers to how far away something is from 0. So here's 0 on a number line. We know that we're going to involve the number 3. And we know that there's two numbers that have an absolute value of 3. One would be positive 3, one is negative 3. Okay, and I'm just trying to explain what this means right here because this might be a little bit confusing. The inequality sign faces the same direction for the positive number but changes direction for the negative number. What does that mean? Alright, so take a look at this number line. So this right here is telling us we want distances that are greater than 3. That's what that says. The absolute value means distance. We're looking for distances that are greater than 3. So let's kind of get a visual right here. So here's our two distances at 3. Hopefully this makes sense to you. If I shade in this direction, that is going to give me distances that are greater than 3, right? You have 4, you have 5, and so on. Those are all greater than 3. So the way that you could say this using an inequality, you could say x is greater than 3. That's where I'm shading. And that's what this means. It says the inequality sign faces the same direction for the positive number. So if you look at this right here, I'm taking x, I'm taking 3, and this is facing the same direction. X is greater than 3. That's what this inequality says right here. Second part of this says it has to change direction for the negative number. So what does that mean? Well, we want distances greater than 3, so now I'll use a different color here. If you look at this part of the graph, we have to shade in this direction for distances greater than 3 over there. So like negative 4, negative 5, and so on. That would put us at a distance of more than 3. So the question is, how do I write an inequality for that part of the graph? And the answer is I would say x this time is less than negative 3. So this is what this says. It says you have to change direction for the negative number. So I'm going to take this right here, I'll put an x, and I'll put the negative number. And now this sign used to be opening towards the x, now it's going to open away from the x. It's going to be less than negative 3. That's what that says right there. So let's try to actually solve some of these right now. So number 1, just to point out a common mistake here, number 1, we don't want to add the 10 and the 8 here. That would be an order of operations error. Order of operations says we have to multiply before we add, and you can see this 8 is actually getting multiplied by the absolute value. So what we need to do is clear away the 10, so we'll subtract 10 from both sides. So that goes away. We're left with 8 times this absolute value, and that's greater than or equal to 34 minus 10 is 24. Okay, we're not able to do anything yet because it says everything with the absolute value has to be cleared away, and that's not true yet. There's still an 8 there, so we'll divide by 8. We can't distribute the 8 because this is not a parentheses, this is an absolute value, so we have to get rid of the absolute value first. Alright, so now we're down to n plus 8, and that is greater than or equal to 24 divided by 8 is 3. Okay, now we are at this step that we just mentioned, which is when everything but the absolute value is cleared away, we're going to split into two, not equations, but these are inequalities because they have a greater than sign. This is going to face the same direction for the positive, and it will change direction for the negative. So let's see what that looks like. Okay, so we're going to split this into two different inequalities. N plus 8 is going to face that same, the sign is still facing the same direction for that positive 3, but it's now going to flip directions for the negative 3, and we saw why in that picture that we did just a minute or so ago. So now let's solve this like we normally do. We'll subtract 8 over here and also over here. So we have n is greater than or equal to 3 minus 8 is negative 5. And over here, negative 3 minus 8 is negative 11. So now let's try to graph that. First thing is ask yourself, when you put these circles on the graph, are they going to be shaded in or not shaded in based on that. And in both cases we're going to have circles that are shaded in because n is not only greater than, but it's greater than equal to. Or right here it's not only less than, it's less than equal to. So we'll shade those in. N is greater than or equal to negative 5. Where I'm shading right there, that's the direction of greater than negative 5. And right here, it says n is less than or equal to negative 11. And less than means shade that way right there. So that's exactly how we would solve it. And that's how we show. By the way, this is called an or statement. Either n is greater than that or less than that. You can see why from the graph this is in two different regions and n can't be in two places at the same time. Alright, if you haven't tried it, I encourage you to pause the video and try to do number 2 the same exact way. Alright, so let's start off the same way. We will add 1 to both sides so we can clear this away. So we have 3 times x minus 3 less than or equal to, and then 2 plus 1 is 3. Then we need to get rid of the 3 by dividing both sides by that 3. So we're left with x minus 3. Absolute value of that is less than or equal to 3 divided by 3 is 1. Okay, now we can do this. Everything with the absolute value is cleared away. We're going to split it into 2. And the sign is going to remain facing the same direction for, in this case, positive 1. So x minus 3 less than or equal to 1. Still facing the same way. It's still less than or equal to. And it's going to change direction, so now it's greater than or equal to the negative version of that number, so negative 1. Now we can solve this by adding 3 right here, and by adding 3 to both sides over here. So we'll get x is less than or equal to 1 plus 3 is 4. And then over here, x is greater than or equal to negative 1 plus 3 is 2. So once again, because it's greater than or equal to, less than or equal to, for both 2 and 4, we will shade those in with solid circles this time. This right here is saying x is less than 4, so I'm going to shade to the left. This right here is x is greater than 2, so I'm going to shade to the right. You can see this is called an AND statement because x is both of those things. It's both greater than 2 and less than 4. So a little bit more compact way of writing that is you could say, just like up there you can see that this is where x is kind of sandwiched in between these things. You can write this thing right here a little bit more compactly. You could say x is greater than or equal to 2 and at the same time less than or equal to 4. So that is another way of writing this thing down here. So that's how you solve absolute value inequalities. Hopefully it makes some sense.